One of the three forms that a quadratic can be in for graphing is called vertex form. And this is actually the same as our transformation form, where it was the ax minus h squared plus k. So it's called vertex form because we can quickly identify the vertex of the quadratic when it's in this form. So the vertex, which is that turning point, is located at h comma k. Right? So remember that h here is a minus h. So you always do the opposite of whatever it is for your vertex. All right? And then k is what k is. So if we look at this example, we're going to first find the vertex, and then we're going to make an xy chart to fill in a few more points. So here our vertex is going to be based on the positive 3 and the positive 4. So it's the opposite of h and k. So it'd be minus 3 or negative 3 and 4. That would be the vertex of this quadratic. Okay, so if I plot that just right off the bat in red, negative 3, 4 is right there. Now, since our quadratic has a negative a value, that means that our quadratic is going to open down. So I know that it's going to go down, and the vertex is that turning point, so that's going to be the maximum. So we're going to make a little xy chart to fill in a few more points to get a good feel of how quickly or how slowly this quadratic moves downward. So we always start with our vertex, and that's at negative 3, 4. And then we're just going to pick the next 2 points. I always go in increasing order. So negative 2 and negative 1. We'll plug those in, and we'll calculate where they would be. So for negative 2, it's negative 1/2, negative 2 plus 3 squared plus 4. If you do that, that is 3.5. And negative 1 would give us 2. So let's plot those points in blue. So negative 2 is 3.5, and negative 1 is 2. Now, if you look at the graph right now, that doesn't look very quadratic. It just goes down on the right side. Well, a nice thing about quadratics is that they're symmetric over where the vertex is. So we can draw like a vertical line through the vertex and know that any points on the right of the line can be reflected to the left side, and there would be a point there as well. So what I mean is this point here at negative 2, 3.5 can flip over right there, and the point negative 1, 2 can flip over to be there. So however far away they are from that line of symmetry, you go that same distance across it, and there's another point, the reflection point on the other side. Now this looks like a nice quadratic. So if we connect the dots and follow our normal path of what a quadratic would be like, it would look like this. So when you're graphing quadratics, all you need are, for the standard form, is the vertex, 2 more points on one side, because then you can reflect them over that symmetry line, and then you'll have your nice quadratic.